Hello all, I Dr. Nidhi Sharma, Assistant Professor Chemistry from AISSMS IUIT Pune. Welcome you all in today's lecture. My today's topic is spectroscopic techniques. In spectroscopic techniques, I am going to discuss about the working of UV Visible Spectrophotometer. So before we study about the UV Visible Spectrophotometer, let's see how it is going to work. When the electromagnetic radiations are subjected to matter, the interaction between the radiation and matter takes place, and it on the basis of the wavelength of the radiation, different changes occurs inside the matter. As you can see, if suppose X-rays are going to be there and if it interacts with the matter, the bond breaking, ejection of inner shell electron of the atom takes place. If suppose it is ultraviolet and visible radiation, then it causes the electronic excitation. This is the excitation from lower to higher energy state. If the infrared radiation interacts with the matter, it causes the molecular vibration transition, means excitation within the same energy level but in vibrational energy level. If the matter is subjected with the microwave, like when the interaction takes place between microwave and the matter, the rotational transition takes place. Again, the excitation is going to be within the same energy level but in rotational energy level. Radio frequencies causes nuclear spin of the atom. So all the matters, all the electromagnetic radiation spectrum causes different changes in the matter. This is, as you can see, as we can see, this is the electronic excitation from one lower energy level to the next higher energy level. The electronic excitation takes place. This happens when the matter is subjected with the ultraviolet or visible radiation. So this is called electronic excitation. This is electronic excitation from one energy level to another energy level. But if the matter is subjected with the infrared radiation, then the molecular vibrational transition takes place. These vibrational levels are present in the energy level, in one energy level. As you can see, these are the vibrational energy level. So now the electron transition takes place but between the vibration level. If the matter is subjected with the microwave, then rotational energy level transition takes place. And then after that, the translation. Thus how each and every radiation causes the different transitions. Now let's study about the UV visible spectroscopy. This is the representative diagram of UV visible spectrophotometer. This is a single beam spectrophotometer. This is light source. This is collimator. This is the monochromator, prism of grating. It consists of exit slit, entrance slit, exit slit. This is a cuvette in which we keep the sample solution. This is detector, and this is a digital display. Now I am taking the animation help. This is going to explain you how the UV visible spectrophotometer going to work. This is how it looks like. This is UV visible spectrophotometer. Now this is a light source. From light source, the radiation, polychromatic radiations is coming, and then after that the interaction is taking place. Now how it works, as you can see, from the light source, the polychromatic light is coming. It passes through the entrance slit. After passing through entrance slit, it passes through the collimator lens, a convex lens which is placed between the source and monochromator to converge the radiation at the center of the monochromator. Then after that, the monochromator, it is the optical component that converts the polychromatic light into monochromatic light. So common monochromator used are prism, diffraction grating and absorption filter. So here we can see this is a diffraction grating. Now after grating, you are getting, like, suppose if white light is coming, it is divided into 7, it dispersed into 7 colors. Now after that, as you can see, the incident radiation, it is of monochromatic light. Monochromatic light means single wavelength light. When this single wavelength light passes through the homogeneous solution, the absorbance takes place, and after absorbance, as you can observe that the intensity of transmitted light is going to be less. You can observe the intensity is less. This is called the transmittance of light. And then after that, this is going to be recorded with the help of detector. Now the function of detector is to convert the light radiation energy coming from the sample cell into electric signal. So common photodetectors are photocell, photomultiplier tube. Inside the detector there is amplifier as well. Alternating current generated in the photocell is transferred to the amplifier. Generally the current generated in photocell is very of low intensity. So the main purpose of amplifier is to amplify the signal many times so we can get the clear and recordable signal. And finally this is going to be the recording device. Most of the time amplifier is coupled to a pen recorder which is connected to the computer. So the computer stores all the data generated and produce the spectrum of the desired compound. So this is how it is going to work. If we talk about the different light sources, like what are the light sources which can be used. So like if UV radiation, then deuterium lamp, hydrogen lamp, tungsten lamp, any of the lamp can be used. If the visible radiation is going to be there, then tungsten, mercury, carbon and monochromator. If quartz prism is used, then UV region. And if glass prism is used for that visible region. These are the wavelength selectors. This is cuvette, which is sample holder. So if quartz cuvette is there, it covers the 200 to 700 nanometer range. Plastic or glass cuvettes cover the visible spectrum. As a detector, phototube, photomultiplier tube, photovoltaic tubes are used. This is an example of phototube. Like you can see, this is a diagram, how it works. So thank you all. This is all my presentation. Hope you understood the concept of the working of UV Visible Spectrophotometer. Thank you.